determination of safe bearing capacity based upon the Prandtl theory. So Terzaghi assumed that depth of footing is less than width of footing. He also assumed that length to width of footing ratio is greater than 5. Length to greater than 5. Load transfer from the structure is vertical. So load coming from the structure is vertical, and base of footing is rough. In case of failure, it follows the general shear failure. So in case of failure, it will follow general shear failure. There will be 5 zones. First zone will be the stage at the stage of elastic equilibrium. It will sink along with the footing, and to zone 2 on either side will be radial shear failure zone, which will have logarithmic spiral of radius r from the corner of the footing, and third will be the Rankine passive zone. And this failure will not extend to the surface, and the shear strength of soil above this horizontal has not been considered for the analysis of safe bearing capacity by the Terzaghi. And the load coming from the structure will be uniform. It will uniformly distributed over this horizontal surface. This all assumption he has made while deriving his theory. And there will be two force acting downward will be responsible for the sinking of the footing, and there will be four force acting upward will be responsible for holding or preventing falling of this footing. So this is two force, the load coming from the structure, that is QU, at the state of equilibrium. It will be in the plastic equilibrium. This soil will be in the plastic equilibrium, and weight of this wedge. Load coming from the superstructure, weight of the wedge will be responsible for sinking the footing, and the passive pressure from the soil, because once it will sink, it will have passive pressure over the soil. So passive pressure from the footing, cohesion force, and surcharge weight. This all will be responsible for holding the footing in equilibrium state, and the shear force acting over this face, this plane face, will also be responsible. So force lateral earth, this is passive earth pressure from the soil, cohesion force, सरचार्ज फोर्स, जो सरचार्ज से फोर्स आएगा, एंड द shear force acting at this phase due to C and phi will all be responsible for holding the footing in equilibrium state. Just कि इसका जो अर्थ प्रेशर होता है, it will have passive this thing, so it follows the Rankine अर्थ प्रेशर theory. तो Rankine अर्थ प्रेशर theory में उन्होंने बताया that whenever this retaining wall face is moving inside, there will be pressure from the earth onto the retaining wall. So there will be three pressures. One will be due to earth, another will be due to cohesion, third will be with the charge. And this will have the vertical, whatever vertical component is there, the lateral earth pressure will be multiplied by the respective coefficients, lateral earth pressure coefficient. So for the earth pressure, it will be K gamma. For cohesion, it will be Kc, and for the surcharge, it will be Kq. So now this wedge will act as a retaining wall. So pressure, we will have the normal pressure acting at the at this phase. We are interested to have the vertical component of it. So we resolve it and we find out the vertical component. In this case, if this is the H is the vertical component, so P gamma will be half gamma K into H square. In case of cohesion, it will be PC, CKCH, and in case of surcharge weight, it will be Q into KQ into H. This we will use in proving the determining the ultimate bearing capacity of the soil. So there will be two force coming from the downward direction, that will be contact pressure of the footing over the soil. If Qu is the force coming from the top, this will be width B, and say for unit length. So area will be B into 1 into Qu. So contact pressure from footing will be Qu into B into 1, and the weight of wedge which will be sinking, which will be going along with the footing, its area will be half unit weight of soil into half into width divided by into multiplied by height of the wedge. So half into B into H. Now this H we need to convert in the term of footing width. So it will be gamma S into V into H is nothing but H is, we know tan phi, this is a phi angle, this is phi. So tan phi will be H over B by 2, and we can say this H will be B by 2 tan phi. So replacing it H by B by 2 into tan phi, rearranging it, we get 1 by 4 gamma unit weight of soil into V square into tan phi. So these two force A and B will be responsible for sinking the footing, and there will be four force C due to earth cohesion, अर्थ प्रेशर की वजह से जो उसका वर्टिकल कंपोनेंट होगा, कोहेजन का जो वर्टिकल कंपोनेंट होगा, सरचार्ज वेट का जो क्या कहते हैं जो वर्टिकल कंपोनेंट होगा P, and shear force acting at this force. So 2P and 2C. This 2P is nothing but earth pressure P gamma, PC and PQ, and this is a cohesion force at both the face of this triangular portion, this wedge. Now what we determine the downward force. Downward force is what? Qu into B plus 1 by 4 V square into unit weight of soil into tan phi, and upward force is 2 times pressure, earth pressure P gamma plus due to cohesion force PC due to surcharge PQ plus due to shear force 2 into C. Now we know P gamma is the vertical component of acting to hold the wedge, vertical component acting to hold the wedge, it will be half gamma H square K gamma, PQ will be Q into H into KQ, and PC will be C into H into KC, and this shear force will be C into B by 2 tan phi. Because this is acting like this, we also need the vertical component of this will be C into B by 2 tan phi, 2 into B by 2 tan phi. Now we input all this, half into gamma H square into K gamma, Q into H into KQ, C into KC into H, 2C, and H we have replaced by B by 2 tan phi. Now all this we need to arrange to find out NC, NQ, and gamma. NC is given by tan phi, then lateral earth pressure coefficient for the cohesion plus 1, NQ is lateral earth pressure for the surcharge into tan phi, and N gamma is half tan phi into the lateral earth pressure coefficient for the surcharge into tan phi minus 1. All this we need to rearrange as it has been arranged here, and we can find out QQ is equal to C into tan phi KC plus 1, Q KQ tan phi NQ, half gamma B half tan phi K gamma tan phi minus 1. This term is a NC as we find out from here. Kq tan phi is NQ. Kq tan phi is NQ, and half tan phi K gamma tan phi minus 1 is N gamma. Input this NC, NQ, N gamma, we find out ultimate bearing capacity of the foundation CNC QNQ plus half V gamma N gamma. In terms of net bearing capacity, ultimate net bearing capacity, we have to subtract gamma into D. So this will become NQ minus this will become NQ minus 1. So with this we completed how to find out ultimate bearing capacity of soil as per the Terzaghi. This is also given in the IS 6403. Thanking you. Thank you.